Okay, this first few are going to be squares or cubes. Alright, this guy right here. First move. You got to pull out, divide them both by 5. So let's divide them both by 5. If you divide them both by 5, it's going to be 5 times 4b squared minus 25. Okay, now what's got to catch your eye is these are both perfect squares. So because they're both perfect squares and there's no middle term, like there's a middle term here, they're got to be conjugates. So it's going to be 5 times 2b plus 5, 2b minus 5. So this guy right here, the bottom left, 20v squared, 100v, 125. Let's divide each of these. If you divide all these by 5, you're going to get 5 times 4v squared plus 20v plus 25. And now it starts with the perfect square and ends with the perfect square. But now you have a middle term, so this is going to look, it's not going to be conjugates. Square root of 4v squared, that's going to be 2v. And 2v squared of 25, that's going to be 5 and 5. But the middle is 20v, so it's going to be plus and plus. And they get 20v's because you're going to get a 10v there and a 10v there. And that's 10v and a 10v is 20v. Okay, let's work this guy. 8x squared minus 8x plus 2.
Hey, wait. Quick question.
Let's... Okay, this guy, if you divide them all by 2, that's your first move. It's going to be 2 times 4x squared minus 4x plus 1. And again, that's a perfect square. That's a perfect square. So it's going to be 2x minus 1 squared. Okay, now this guy, as soon as you see the exponent is a cube, and it's going to fit, this is going to fit our sum of cubes. So our sum of cubes, first you got to figure out what the base is. This is not 125. You need to see this as 5 cubed, m cubed, plus 6 cubed. So first move, you got to figure out what the bases are. The base is going to be 5m, and the base is going to be 6. So the sum of cubes, you take the base plus the base, and then you square the first base. 5m times 5m is going to be 25m squared. And then you subtract whatever these bases are times together. So that's going to be 30m. And then you add whatever this base is squared. 6 squared is going to be 36. So if you got a cubed plus b cubed, you need to have a plus b. A squared minus ab plus b squared. And then if it's a cubed minus b cubed, it's going to be a minus b, a squared plus ab plus b squared. So those 4 are cubes and squares. If you come across these next few, okay, this guy right here, that's a cube. Okay, let's go back to this one. Thank you, Celeste Stevenson, Delta High School, class of 2016. Okay, this guy, your cubes so far, I don't know if we're done with the cubes. Because, let's see, if you break this down, this is done, but this guy looks a lot like this one we just barely did right here. So, the 5m plus 6 is done. But if we, I mean, that's a perfect square. That's a perfect square. You can factor this down into. Can you factor it down to 5m minus 6 squared? 5m minus 6 times 5m minus 6. Yep, pretty sure you can. So.
Wait, so if we, on the test, if we just leave it like the top, will it be wrong?
Alright, now let's go to this guy. So it's a cube. But 16 is not a cube and 2 is not a cube either. Let's divide these both by 2. So let's go 2 times 8x cubed minus 1.
That doesn't really work.
Now you're in business.
5m.
Okay, let's go back to this guy right here. We got a problem.
Are you kidding me right now?
I'm not sure this is a perfect square. Because if you go 5m minus 6 times 5m minus 6, that gives us the 25m squared. But if you do the 5m times a minus 6, that's a minus 30m. And if you times these guys, that's another minus 30m. And if you times these guys, that's a plus 36. So we get our plus 36 and we get our 25m squared. But we only need one negative 30m, and we got two here. If you add these up, that's 25m squared minus 60m's plus 36. So we got too many m's because we only got to have 30m's. So your answer is just leave it. Just leave 5m plus 6 and then square the base, 25m squared minus the bases times together, 30m plus the second base squared. Leave it. Call it good right there. That will not factor down any further. Just leave it like that. Okay, this cube. Now, if you divide them by 2, now the cubes show up. You need to see this as 2 cubed x cubed minus 1 cubed. So now it's going to be the base, 2x minus 1, times the base squared, that's 4x squared, plus the bases times together, that's 2x, plus the base squared, that's 1. Done. Okay, now the next one. Let's look at this one. X to the 6 minus 64. Okay, this one feels a lot like conjugates. Feels a lot like conjugates. So if you go x cubed minus 8 and x cubed plus 8, when you times x cubed, that's going to give you your x6. Okay, that's it. X cubed minus 8, x cubed plus 8. But now that's a cube and that's a cube. And these cubes, 8 is also a cube. Never ends. So the base here is x, and the base here, that's the same as 2 cubed. That's x cubed minus 2 cubed, x cubed plus 8 cubed. So let's do the difference of cubes. The base minus the base times the base squared plus the bases times together plus the base squared. And this one right here, the sum of cubes is going to be the base plus the base times the base squared minus the two bases times together plus the last base squared. So you should have 1, 2, 3, 4 factors when you factor x to the 6 minus 64. Okay, these other two feel a lot like difference of squares too, feel a lot like conjugates. X to the 4th minus 625. If I take a square root of that and a square root of that, because that's what we did here, we just took the square root of that, these are perfect squares. So if you take the square root of x to the 4th, that's going to be x squared. If you take the square root, does 625 have a square root? 625.
Wait, can't you just take like the square root of the whole thing and it'd be like x squared minus 25?
Now, so you got conjugates and they're both squares. Now this guy's not done because x squared minus 2, that's still a square root. That's a square root. So you can break that down to x minus 5 and x plus 5. But this one, you cannot break this down. Kind of like we tried to break this down. It won't work because we couldn't get it to equal 30, negative 30 m's. This will not work. You cannot break down x squared plus 25. So your final answer, if it was equal to 0, if it was an equation, yeah, you could do. If you were trying to find the solutions, yeah, you could do imaginaries. But since it's not an equation, you just ask the factor. Just You don't need to. So this should factor into 1, 2, 3 factors.
If we did find the solution,
Oh. Okay, x to the 6 minus y to the 6. So they're both perfect squares. It's going to follow the same model as these other two. So they're conjugates. X cubed minus y cubed times x cubed plus y cubed. And now this is a difference of cubes, this is a sum of cubes. The difference of cubes, you take the base minus the base, times it by the base squared plus the two bases times together plus the last base squared. The sum of cubes, you take the base plus the base, times it by the base squared minus the two bases times together plus the base squared. So this one is exactly like this one above it. It should break down into 1, 2, 3, 4 factors. Go. Alright, here's what they want. They give you a model that represents parasites. They want to know t is time, and time is in days. So they want to know, according to this model, how many days is it going to take for this population to equal 0? They want it to equal 0. They want you to find the roots. They want you to find what you're going to plug in to make it equal a 0. So you just go 0 equals t cubed plus 5t squared minus 4t minus 20. This polynomial has 4 terms. I'm going to group them. Let's group, I'm going to group these two together. T cubed and 5t squared, I'm going to divide that by a t. I'm going to divide that by a t. So no, you can divide by more than t. Divide by t squared. If you divide them both by t squared, it's going to be t squared times t plus 5. Okay, now this next group, a negative 14 and negative 20. So that's the hint. If you've got 4 terms or more, you want to group them. So negative 14 minus 20, I'm going to group these two. I'm going to divide these two by a negative 4. If I divide them each by a negative 4, it's going to be a negative 4 times t plus 5. So now look at my first group and look at my second group. Your final answer, you're going to have t plus 5. Both those groups have a t plus 5, and in your other quantity, it's going to be what you divided by. It's going to be t squared minus 4. Okay, now set that equal to 0. Okay, this guy you should recognize is, these are going to be conjugates. So this is t plus 5 does that go to t minus 2 and t plus 2? There we go. So you should see that you can break this guy down, t squared minus 4 to t plus 2 and t minus 2. So now when is t going to give you a 0? It's going to give you a 0 if you let t be a negative 5. If you let t be a positive 2. Or if you let t be a negative 2. So these are the 3 instances when the population is going to be 0. When on day negative 5, day 2, and day negative 2. So at which times does the population reach 0? At day negative 5, day 2, and day negative 2. But that's the answer to C. Are any of these unreasonable? You can't have a negative day. So the only day it's going to be 0, on day 2 it's going to be 0, because you can't have a negative day. So the negative days are unreasonable. You don't want to turn that into your boss, or else he will laugh at you. 'Cause there's no such thing as a negative day. Okay, this one right here. Yeah. The negative days are unreasonable. Okay, this one right here. You will not believe the number of children that if I give them a plus b squared, they believe the answer to be a squared plus b squared. This is a... If you've got a plus b squared, what they want you to do is a plus b times a plus b, which is going to be a squared plus ab plus ab plus b squared. So it's going to be a squared plus 2ab plus b squared. This is your answer. If you have a group squared, you do not take the exponent to the a and to the b and call it good. This is not the answer. This is a huge no-no. But everyone does it. So, Harley, find a counter example. You need to find a counter example to prove this false. So Harley, here's what you need to do. You need to let a equal some value, and then let b equal some value, and plug it in, and you will see that they're not equal. What do you want to let a equal? If you want to let a equal 1, what are you going to let b equal? 1 as well? Oh, well, let's try it. Let's try it. So if you let a equal 1 and b equal 1, then what's this first one going to be? A squared plus b squared is going to be... That can be 2, right? Now if you do 1 plus 1 squared, Harley, that's going to be 4, yeah. So look, this one should give you a 4, this one gives you a 2, so it does not work. So there's a counterexample. There's probably millions of counterexamples. So the big idea is these two are definitely never, ever equal. Harley.
What does it mean when it says
Double
double?
go. Okay, if it's got a double root of 1, that means you plug in 1 and it gives you a 0. So it's got to be x minus 1 times x minus 1. This will give you a double root of 1. When I plug in 1 minus, there's my zeros. And a double root of negative 5, so it's going to be x minus 5. No. It's x plus 5, because if I plug in a negative 5, that's what gives me the 0. X plus 5. Now, I'm going to times these two together. In my head, if you got x minus 1 times x minus 1, that should be x squared minus 2x plus 1. And I'm going to times these two together in my head, x plus 5, that's going to be x squared plus 10x plus 25. Now it's going to be nasty because I need to take this polynomial and this polynomial, and I need to multiply them together to create one super polynomial, x squared times x squared. That's going to be x to the 4th. X squared times 10x, that's going to be plus 10x cubed. X squared times 25, that's going to be 25x squared. Okay, now a negative 2x times x squared is going to be, I'm going to stack them, a negative 2x cubed. A negative 2x times 10x is going to be a negative 10x squared. A negative 2x times 25 is going to be a negative 50x. And then the last, I'm going to do 1 times x squared is going to be 1x squared. 1 times 10x is going to be plus 10x. 1 times 25 is going to be plus 25. And now I just combine all my like terms. So it's x to the 4th. I got a couple cubes. They're going to total give me 8 cubes. These squares are gonna total and give me 16 squares. Is that right? You're, oh, is it 6? 6 or 16? 16! What's 25 take away 10? And then you got a plus 1. Uh-oh, this might be a minus 20. Dang it! Oh, look, you're right. A negative 2x times a 10x, that should be a negative 20x squared. So, yeah, it's not 16, it's just 6x squared. Nice eye. Okay, these, did you guys get negative 40x? And plus 25? So the polynomial, just write y equals the function that gives you two double roots. Double root of 1 and double root of negative 5, this is it right here. This will give you two double roots. So if you're given a polynomial and one of its factors, you got to figure out the rest of the factors. This one is of the form you can use synthetic division. So synthetic division. Okay, I'm going to put a negative 1 here. I'm going to put a 1 here, a 1 here, a negative 5 here, a negative 5 here, a 4 here, and a 4 here. And then there's my remainders. So the 1 comes from my 5th degree. The 1 comes from my 4th degree. This negative 5 is my cubic. You got to go in order. And if they don't give you, look, if they would have given me a quintic, a quartic, a cubic, and then if they would not have given me that, they would have skipped that, you got to put a 0 there. Because you got to go in order. 5, 4, 3, 2. So if they don't give you something, you got to put a 0 there. So now bring down my 1. Times them. That's going to be negative 1. Add them. That's 0. Times them. That's negative 1. Add them. That's negative 6. Dang it. Dude, was that Tyler? Tyler! This guy times 0, 0. Add them up. That's a negative 5. Times them. That's a positive 5. Add them. That's 0. Tyler, you're loud. Thank you. Thank you very much. You're a good man. A little loud, but you're a good man. Times them. That's 0. Add them. That's 4. Times them. That's negative 4. Add them. That's 0. See ya. So, no remainders. So the factors are going to be 1 x to the 4th minus 5 x squared plus, because this is degree 4, this is degree 3, this is degree 2, this is degree 1, this is degree 0. So x to the 4th minus 5x squared plus 4. But the question is, can you factor x to the 4th minus 5x squared plus 4? Can you rewrite that as the product of two binomials? What's going to times give you x to the 4th? X squared, x squared. What's going to times give you 4, add and give you negative 5? Negative 1 and negative 4. And now let's pull a Celeste. Let's times through to make sure it works. X squared times x squared is going to be s to the 4th. X squared times a minus 1 is going to be minus 1x squared. A minus 4 times x squared is going to be a minus 4x squared. A minus 4 times... Okay, that works. Because that gives you x to the 4th minus 5x squared plus 4. But now, x squared minus 4 and x squared minus 1. Are you done? Are you ever done? You can break this up because these are both conjugates. So this is going to be x minus 2 times x plus 2. This is going to be x minus 1 times x plus 1. So they gave you this factor. So if you times this to all these, here are your other factors. This should total to be 5 factors. 1, 2, 3, 4, 5 factors. Okay, let's do this one. You can't use synthetic unless you use in the box. You can put a negative 1/2 and that'll work. Now, so you can play around with that and try that, but let's make sure you still remember how to do the long division the old-fashioned way. So let's do it the long division the old-fashioned way. If you got 2x plus 1, if you're going to divide 18x cubed plus 9x squared minus 2x minus 1, you just kind of focus on this 2x. What can you multiply 2x by to turn it into a 18x cubed? And you should come up with 9x squared. So if you times 9x squared to 2x, that's going to turn it into an 18x cubed. But you got to distribute it also to the 1. You got times 9x squared to the 1, so you're going to add 9x squared. But now you got to subtract, and you got to subtract both of them. So I'm going to change that to minus, I'm going to change that to minus, and these actually, everything zeroes out. So now you bring down this next one, which is a minus 2x. And a minus 2x, what are you going to times 2x by to turn into a minus 2x? Just a minus 1. So a minus 1 times 2x is going to be a minus 2x. And a minus 1 times 1 is going to be a minus 1. We could actually bring both of them down. Now you got to minus it, change them both to pluses. And it zeroes out. Everything zeroes out. So you have no remainders. So this guy times this guy, your other factor then is going to be 9x squared minus 1. And are you ever done? Can you factor that? Yes, you can. Well, what's going to times give you 9x squared? 3x, 3x. What's going to times give you a negative 1? Add and give you nothing. Minus 1 plus 1. So these two factors, along with this factor, will all multiplied give you 18x cubed plus 9x squared minus 2x minus 1. So always ask yourself if you can break it down. Can you factor it down anymore? Okay, this is the same thing. If I give, this is the exact same type of problem, it's just in context. So the volume of a pool is modeled with this polynomial. If I give you the depth, can you find the length and the width? So the volume equals height times length times width. If I give you the volume and I give you the height, you got to give me the other two. So you got to divide it. So take 2x cubed minus 9x squared plus 7x plus 6, divide it by 2x plus 1. Just like we did, and that will give you the other two factors, the length and the width. Okay, let's leave you to do that on your own. Let's talk about these. Which of the following could be the number of real roots, included any double roots, of a cubic? So it's some kind of cubic. Okay, how many real roots can you have if you got a cubic? So if there's a cubic, there's going to be 3 roots. You know the fundamental theorem of algebra, there's got to be 3 roots. So it could be 3 or 1. Because if it's 3, then it's a real, a real, a real. If it's 1, it's a real, and then the other 2 are going to be imaginary. But you got to remember, imaginaries always come in pairs. They always come in conjugates. So you cannot have a real, and an imaginary. This will not work because imaginaries always got to come in 2s. Okay, what if you've got, what if it's a degree 6? If it's degree 6, there's going to be 6 roots. So what are all the combinations you can have with real? You could have all 6 real, but that's not an option. Then you could have 4 real and 2 imaginary, so 4 is up there, check 4. You could have 2 real and 4 imaginary, or you could have 0 real and they all could be imaginary. So you got to remember, imaginaries come in pairs, conjugate pairs. Okay, now solve these. Here we go. Okay, the first one, you want to divide all these by x. There's a greatest common factor. If you divide them all by x, that's going to be x times x to the 4th plus 2x squared plus 1. Sydney. Now, after you got this move done, can you break that up? Will it ever end? Can you keep going, keep going, keep going? So x. What's going to multiply and give you x to the 4th? X squared, x squared. What's going to times and give you 1? And you can double check it. If you distribute through, that'll give you x 4th. They get the 2x squared because x squared times 1 and x squared times 1. Then you're going to have 2x squared plus 1. Now, you need to find the roots. Because this is degree 5, there will be 5 roots. So here we go. Can you break this down? And can you break this down? Is there any way to factor x squared plus 1? The answer is no. So here we go. Here are your roots. Let's use the product, because no matter what you put, if you got x squared plus 1, there's no way to factor it down, because you can times to get x squared. That's got to be x and x. But what's going to times give you 1? It's either got to be a 1 and a 1 or a negative 1 and a negative 1. Because a negative times negative will be a positive, or a positive times positive. But you have no middle term here. And if you distribute these through, you're going to have x squared minus x plus 1. And they're not going to zero out. They only zero out if one of them's positive and one of them's negative. And for one of them to be positive and one of them to be negative, that would times and give you a negative 1. So they only zero out when they're conjugates. Now, let's figure out what the zeros are. What's going to make this a 0? What are you going to put in place of x here to make this a 0? 0. And then what are you going to put in place of, if I can find this, I just copy and paste it, because these two are the exact same. So x squared plus 1 equals 0. I'm going to figure out, if you want to know what's going to make it 0, set it equal to 0 and solve for x. Minus 1, x squared equals a minus 1, square root, so x equals plus or minus I. So here's your answers. X is 0, x is I, x is minus I, x, and copy and paste it, because that's what this is going to be, I and a minus I. So 1, 2, 3, 4, 5 roots, because it's a quintic, but you can just, since these two are double roots, you can just write x is 0 or a plus or minus I. Okay, now this is a cubic. An 8 is a cube and 27 is a cube. So let's view this as 2 cubed x cubed minus 3 cubed. So if we view it as 2 cubed x cubed minus 3 cubed, it's going to be 2x minus 3 times the first base squared. 2x times 2x is going to be 4x squared. Plus the bases times together. 2x times 3 is going to be 6x. Plus the last base squared. 3 times 3 is going to be 9. Okay, I know it's a cubic, so there's going to be 3 roots. Can you factor this down any further? Is this going to break down? So it kind of feels like it's going to be 2x plus 3 times 2x plus 3, but I don't think it is. Because I need 6 x's in the middle, and watch what happens. If you do 2x times 2x, there's your 4x squared. 2x times 3 is going to be 6x, and 3 times 2x is going to be... I got too many x's. I got my 9, but I got 4x squared. I got 12 x's, and I only need 6 x's. So this is not going to factor down any further. So we just leave it. Now what's going to make this quantity a 0? When x is equal to 3 halves. So just set this equal to 0. 2x minus 3 equals 0. And this, so there's one of my roots. To find your roots out of this mess, use the quadratic formula. Because it's not going to factor down. A is 4, B is 6, C is a negative 9. So x equals a negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So now it's going to be a negative 6 plus or minus the square root of, let's simplify that, 36 minus 4 times a negative 9. Is this 180? So how do you know when you use the quadratic formula? You use the quadratic formula. If it won't factor down, that means your answers are not going to be integers. They're going to be some irrational or rational. They're going to be nasty. If it will not factor down, you got to use the quadratic formula. Oh, shoot. C is probably not a negative 9. Is C a plus 9? Okay, C is a plus 9, so that's going to change things. So does that just make it a negative 180? Let's double check. 36 minus 4 times 9. Dang. Is it negative 108? So it's going to be negative 108. So, 108, is there anything in 108 that we can pull out? 108 is 2 times 54. 54 is a 9 times a 6. That's a 3 times a 3, and that's a 2 times a 3. So 108 is the same thing as 2 squared and 3 cubed. So 108, one of these 2's are going to come out, and one of these 3's are going to come out. So it should be the same as 6 times the square root of 3. So here we go. You're going to have a negative 6 plus or minus 6 times the square root of 3 I over 8. Because it's a negative 108, so it's got to be imaginary. So we factor 108 down to its prime factors. We change it to 2 squared, 3 cubed. Pull out your squares. A 2 and a 3 come out. That's going to give you 6. A 3 is left in. Now, a 6, and an 8. You got to simplify it. Divide all these by 2. It's out. Put it on the outside somewhere. So it's going to be a negative 3 plus or minus 3. And you can put the imaginary here. 3i squared of 3 all over 4. So here are your 3 roots. One of them is a 3 halves, and one of them is a negative 3 plus 3i squared of 3 over 4, and one of them is a negative 3 minus the 3i squared of 3 over 4. Okay, last one. This one feels a lot like these guys right here. The first ones we did. It's a difference of squares. I think they're going to be conjugates. Jeez. Looks. Oh, we've already done that. X to the 4th minus 625. Okay, we have done that. Oh, now it's 16x to the 4th minus 625. So that's going to be a little different. Okay, these are both perfect squares. So it should be 4x squared minus 25 times 4x squared plus 25 equals 0. This one you can break down. And that's going to be 2x minus 5 times 2x plus 5. But this one you're going to have a hard time breaking down. I don't think this one's going to break down. So 4x squared plus 25 equals 0. I know it's a quartic, so there's got to be 4 roots. So this guy, 2x minus 5, make that equal 0, plus 5, 2x equals 5, x is going to equal 5 halves. And so the other one, x is going to equal a negative 5 halves. So there's 2 of my roots. And now the 4x squared plus 25. Yeah, plus or minus 5 halves. 4x squared plus 25 equals 0. Because I've got no bx, Taylor, if I'm missing a bx, I've just got a quadratic and I've got a constant. I got no linear. So this one is probably easier if you just solve for x. So minus 25 minus 25. So you're going to have 4x squared equals a minus 25. Divide by 4, divide by 4. So x squared equals a minus 25, divide by 4. And then square root and square root. So x is going to equal plus or minus. It's imaginary because it's negative. But the square root of 25 is 5, square root of 4 is 2, 5 halves I. So there's 2 roots. And here's 2 roots. So the roots are all 5 halves. One's positive, one's negative, one's positive, one's negative in the imaginaries.